you write multiple Docker images and files, and sort of play around with Docker registries and everything. So yep, we are live, so good to go. So again, I'll first of all set up the agenda and the expectations that what you should be, looking forward to have in this course right now in this entire session. Um, so we'll be covering initially Docker and why we are, learning Docker. We'll try to understand a bit about the history as well. And just a minute. Yep. So we'll try to understand a bit about the history as well, like how Docker came into the picture, what was before Docker, why do we need Docker in DevOps, and DevOps is like a process, right? It's like a culture, and where does Docker exactly fit into the entire pipeline of DevOps? So we'll try to understand that, and we'll also explore topics like containerization, virtualization, and see a small, basic hands-on demo with Docker. Now, again, I'm maintaining a GitHub repository where all the files, PDF notes, and the hands-on code that we are using, I'm uploading there. So feel free to hop into my GitHub account. I'll share the link in some time, and you can find all the necessary code details and code bases and everything there. So yeah, let's begin. So what is Docker technology, right? So again, Docker technology, like Docker is a tool, and as a whole, we call it containerization as a technology, and it implements the container-based virtualization technologies, right? So to understand this entire definition, we'll have to sort of jump back and see what exactly drove the innovation of Docker or containerization as a whole. So we'll skip Docker for some time. We'll try to understand why Docker came into the picture from the topic of containerization, right? So let me share my iPad screen. Um, just a minute. Cool, amazing. So let's try to understand this in a small scale, right? So like initially, let's say in traditional practices, right? So let's say you have built an application. So you have your application here, right? And when you're trying to work around with your application, you have to deploy it to a server or something like that, right? So you'll deploy this to a particular server. So let's say this is a server that you have, and your application lies here now. This is what happens in traditional practices, right? Now let's say you are a company who is trying to build multiple applications. You're working on multiple products or maybe microservices, and you want to deploy them into different servers. Now for this purpose, initially, like following the traditional practice, what you will do is you'll have for app 2, let's say, you'll deploy it to another server, and this is where your app 2 will lie, right? Now interaction between these two servers is going to be difficult, as well as there are multiple constraints. Like this is not at all a cost effective process, so there are major disadvantages in cost investments, right? Operating system, resource requirement for each server, and also a lot of manual labor, right? So a lot of manual work has to be done by the operations team, right? So this was something that was done, initially, like in the old days of technology, and then came a technology known as virtualization. So there is a company, I hope you guys have heard about it. The company's name is VMware, right? Now VMware came up with the technology which is known as virtual using virtual machines. So again, if you don't know what is a virtual machine, you don't have to panic at all. You must have heard about the term virtual machine, like playing around with virtual machines, VMs, dual boots, and stuff like that, right? So something similar to that. So VMware gave us something known as virtual machines. Okay. Now, virtual machines, what they did was they entirely changed the ecosystem. Okay. So let's say this is the block, right? And this is where my infrastructure lies. Infrastructure as in my laptop, my every sort of system files and everything, right? So in virtualization, above infrastructure lies the operating system. So let's say you're trying to build an application, you're trying to deploy an application, you will need an operating system to do that, right? To play around with that. So you have this operating system here, right? And then you will have different applications hosted over here, right? The disadvantage again in VMs or virtualization process was, again, that initially we'll require a dedicated OS to work around with virtualization. So, like when I say dedicated OS, let's say Windows, Linux, or maybe anything, right? You need to define an entire operating system to work with application one. You need to define an entire operating system to work with application two, right? Now, even then, like the virtualization process, it solved most of the problems that we were encountering here, but still, then there are a lot of disadvantages in terms of cost, in terms of resource. So let's say for each applications, I'll define an entire CPU requirement, I'll define the resource, the data, and all these things, and probably I'll not be even using all of it, right? So let's say app one uses 5% of what I've defined, the 95% is still a wastage here, right? So how can we sort of work around with this? So initially, when virtualization was in practice, companies like Google, Amazon, Microsoft, they were implementing a different technology, okay, and they did not name it, but they were implementing it in a different way, right? Which the technology is known as containerization, right? So containerization then came in picture, right? Now, what is containerization, right? So again, as I mentioned, Google, Amazon, and everyone else, they were playing around with different sort of what to say technologies, and they were implementing this beforehand itself, right? But they did not name it as containerization. So containerization initially started with the process of investing into the Linux kernel. So we have this Linux operating system and we have the Linux kernel, and folks came in together from different companies and they started contributing to the Linux kernel, right? And the contribution that they were making was to reduce this. How can we become independent of OS? Okay, so the objective here was becoming independent of operating system, right, while working with application. So let's say if I'm making an app, right, and I want to share to my developer friend, in developers, in us we have this culture, right? If I make something, I want to share it to my friend and say, hey, try it out, and he'll probably try it out, and because of some packages or maybe some libraries, maybe some deprecated versions of libraries, he'll not be able to use it, and then he'll ping me, hey, I'm not able to use it, but then I'll say the famous word that it works on my machine. Why does not it works on your machine? So how can we overcome that? How can we overcome the operating system barrier that we have while sharing data, or while sharing applications, or while sharing running applications as well? How can we do that? So the objective was that. Then came containers into the picture, and the entire technology of containerization. So let me jump back to the presentation again. um, so I hope virtualization is clear to all of you now. So virtualization is nothing but a technology which was introduced by VMware. The objective of this was entirely based on sort of getting in VMs rather than shifting into direct servers, investing so much of money, and using dedicated operating system for dedicated applications. But again, that was also not fair, because we were still sort of having some resource allocations in terms of OS, in terms of data, in terms of CPU, which is not fair enough. Cool. So moving ahead, then came containerization in the picture, right? So this is a picture, right? And if you see, there is a famous, this is a famous example that we often use while explaining containerization, which is a shipment example, right? If you see this picture, behind this we have a ship which is loading some containers, and this developer is currently working on this, right? So again, I'll just cover a bit about virtualization in terms of the diagrams, right? So this is a pre-virtualization world, the traditional world. This is a physical server, then you have a host operating system over which the libraries and applications was there. And the problems was, of course, the huge cost, the slow deployment processes, and these are not easily portable. The migration is not easy. So of course, these are the main three major problems. And then came virtualization. So in virtualization, there was a term, a hypervisor. Now, hypervisor is what introduces a VM. Okay, so in virtualization, we have our physical server, and then that is the infrastructure, right? And then we have the OS, and then we have the hypervisor. over which our guest OSs can run. Now, if you see here, for app 1, we have another first guest OS. For app 2, we have another guest OS. For app 3, we have another guest OS. So this is uh, like cost efficient and this is easy to scale. But again, we are duplicating kernel resources, right? So we are duplicating OSs here. Why do we need this? And of course, the application one which works on Windows may not work in Linux, right? So application portability was also another major query. So how can we sort of come across, how can we solve this issue? Then came containerization, right? So this is the container based virtualization. You can see the different examples, like the clear example with virtualization as well, right? So in containerization, we have infrastructure, right? And then we have the operating system, right, the host operating system, and then we have the container engine, right? So what is a container engine and how does it look like, we'll cover it in some time, right? But then over the container engine we have app 1, app 2, and app 3 running, right? And all this together are known as containers. Each one is a container. You can consider it to be like it, right? So the major benefit of this entire process was to reduce the dependency on OS, right? So now if you see, we are not actually dependent on OS. We don't really care about what is the operating system. The containers, what they did was they came up with a terminology which is known as runtime isolation, right? So it basically means when you are having an application and you give it into a container, it will run in an isolated environment, right? So it will not care about what is outside. It will just focus on what is inside, the dependencies, the libraries that you have mentioned, and that's it, right? And that is where it will be working around. And if you can also ask me this question, right, that projects like MongoDB and everything, to run them will require an operating system, of course. How do we get that operating system? And if you don't have an operating system, how do you even run them? Of course, valid question. So in containers, what we do is we define system files. So we don't define our operating system as a whole, but we define the system files that is actually required by Mongo to run, and that's it. So what it ensures is usability. We can use the same files, in different ways, right? Okay. Yeah. So we can use the same file in different ways, right? And secondly, we don't care about, we are not having a resource duplication. We are not leaking resources either. So these are the major benefits of having runtime isolation. So our application will run in an isolated environment, and that was a major, again, success of container technology. Again, the benefits: cost efficient deployments are faster and guaranteed portability. Why guaranteed portability now? Because the application that you're running is not dependent upon any other sort of what to say, operating system, right? So you can directly share your application. Basically you will share the image. Okay, now I'll cover this terms in some time: what are containers, what are image, what are registries. But basically you will share that image, and that image will allow your friend or your connection or your developer colleague to run that application in his local systems, right? So that's how the entire containerization works, right? And so let me deep dive into the architecture a bit now. So let me share my tab. Cool. So if we try to understand the architecture of containers or Docker in specific, right? So let's say this is my architecture entirely, right? So initially, we have something which is known as runtime, right? And then we have something which is known as the Docker engine. So you have probably seen Docker engine in the diagram, right? So this is where the Docker engine lies in the architecture. And then we have something which is known as orchestration. Cool. Now we'll try to understand each of them, in bits by bits, right? So what is a runtime, right? So runtime is something that runs your Docker image, right? Now, what is an image? We'll cover it in some time, right? For now, just assume it to be the medium which will allow your friend to run your application, right? So the runtime, just a minute. Cool. So runtime basically runs your image, right, which is the medium to host or sort of play or sort of work, have the hands-on demo of your application that you have developed in your friend's system, right? And there are different types of runtime, of course. There is a runtime which is known as there is run C, there is container D, right? Again, I'll not deep dive much into them, but just giving you a basic idea. So again, if I have to justify them, there is a low level runtime, which is the run C, right? And then there is high level. So run C works around with downloading images and in sort of using those images. Okay, so when to run an image and when to stop running and contain. So this is like playing around with containers. If I have to define, it's like starting a container and stopping a container, right? And then there is a high level runtime, which is known as container D. This is a CNCF incubated project, right? And this basically works around with managing of run C. So it manages the operations that you did here, as well as the networking, right? So in terms of data sharing, like you're sharing data or maybe fetching something or pulling something. So it works around with that as well, pulling and etc., right? Cool, amazing. So again, that's a runtime, right? Again, basically, I guess you guys have got an overview of what runtime does, right? The run C focuses on starting and stopping the containers. The container D focuses on managing run C as well as pulling and sort of playing around with containers, right? Now again, Docker sort of manages a client server architecture. Okay, so there is a client server architecture in Docker. Okay, so what is a client server architecture? We'll try to understand them, right? So let's say basically, let's say we are running this command of docker run xyz. So let's say xyz is my image name, right? So how does docker actually operate? What is the actual backend operation that is happening here? So we can run understand this with this term, that we have something known as daemon, or we can call it docker daemon. Okay? This is my docker daemon, right? And beyond this, we have REST APIs to support us in communication. And over this, we have Docker CLI. Now, CLI means command line interface. I hope you guys are aware about it. We have had previous sessions on networking, where we sort of basically covered we had a session on Linux. I'm sorry, where we basically covered the entire CLI concepts, Bash, SH, and everything. Right. So let's say every time I run a command, like say docker run image name, what happens is my daemon will send a query, right? It will send a query and REST API will facilitate it to the Docker CLI. And Docker CLI will see, for run this command or this image name, it will try to find it in my local systems. Otherwise, it will go global and find if there is an image existing with this name. And then it will pull that image back to my systems and it will run it on my local systems, right? That's how the entire interaction works. So basically, why I'm covering this right now is to explain you that the client server architecture here is this, right? The client in this case becomes what? My CLI, and my server here is nothing but my daemon, right? So daemon sends a query and CLI acts on it and then sends it back, right? That's the entire operation that is happening, right? So yep, that is pretty much about the Docker architecture. Now again, let's cover the two other points that are left out, right? We have the Docker engine. I'll cover Docker engine at the end, and then orchestration, right? So let's understand what orchestration is and why do we need Docker orchestration. Cool. So let's say you have an application, right? And let's say you have a container, right? This is your container, right? And you have multiple versions of your app, right? So let's say in this container you have only versions v1, right? And so you want to change the versions of this container to v2, and that process is known as ruling updates, right? Now for someone to do this manually, it takes a lot of time, and it's wastage of energy and wastage of resources as well. So how can we sort of overcome this, right? How can we sort of automate this? Basically, automation, this entire ruling update process. This is what is known as orchestration, automating this entire process. What does this mean? It means managing and operating over containers. And the biggest example that we have it for is Kubernetes, which is also known as KX, right? Cool. So again, orchestration will cover in a Kubernetes session, which is upcoming session that is on KX. In this session, we'll try to focus on containerization and Docker, right? So of course, now containerization is clear, right? We use containers, we have different images and everything, but again, there are certain terms which are not clear about. Um, cool. Um, so there are these terms, the famous terms, which is there are container image, what are containers, and then like how does actually this image work, right? I'm telling continuously that I'll share my image and this image will be downloaded, and so someone will pull this image and they'll be able to run my application. So how this entire operation works, right? So it starts from something known as a Docker file. So let's take an example. Okay, let's say I am making a dish, right? I'm preparing a famous dish. Okay, this is my dish. Okay, and I am in Bhubaneswar, right? And I really like this dish, right? Because it's amazing. I have great cooking skills, assume this, right? And I want to share this dish to my friend, let's say Saurav. Right now Saurav stays here, he is in Bangalore. Where is he? He's in Bangalore, right? Now I call Saurav and I'm like, hey Saurav, do you want to try this dish? And Saurav will be like, yes, I want to try, but how can I shift this dish here? Now, according to containerization, I can sort of package it in a container and send it to Saurav, right? But understand, like practically, by the time this dish will reach Saurav, it will be spoiled, right? Similarly, in technological terms, if I say I have a running application which is running, and if I share this application in a container, which is not possible, then Saurav will receive a older version of it, right? Or maybe a version which is not running, maybe it's already stopped, something like that. That the entire process will change. So how do we make around, working around with that, right? So for that we have a Docker file, right? So Docker file is where the entire game starts, right? So we have a Docker file. Now, what is a Docker file? Let's consider it to be like a recipe, right? A recipe of how to cook, or in technological terms, these are like instructions of how to use, or sort of how to play around with my app, right? Now, like if you have learned object oriented programming, you'll be able to relate to this, right? So if I create a flow diagram right now, right? So it starts from my Docker file, it moves back to my image. So I write a Docker file, right? And I run the Docker file, which converts the Docker file into an image. And using that, in that image, whenever I run it, it runs in a container. So that's the entire workflow, right? So if I talk in object oriented concept, right? Image here is nothing but it's a class, which is an encapsulation of variables and functions. And container here is nothing but is an object of this class. So I hope you will be able to relate to this right now. Now, what is a Docker file? Docker file is nothing but it is a medium or a tool, which is, or let's say a file, which is used to create the class. So to create the class, we use Docker file, and object is nothing but it's a reference back to the image, right? It's a running instance of the image, right? That's it. That's what is a container. So if somebody asks you what is a container, define it in one word. So you'll say a container is nothing. It's a running instance of my image. That's it, right? Cool. So that's pretty much about the concepts that we had, again, to cover in terms of the terminologies. Now let's try to understand a bit in DevOps. I said, right, Docker, how, where use DevOps, right? How does it support DevOps? Why does it DevOps come in picture? So DevOps is what? It's a culture, right? So let's say what is Docker, what we are doing in Docker here, right? So let's say we have an application, So in DevOps, we write a Docker file and we create the image. Using that image, we run containers, and that's what we are doing, right? And in terms of operations or manipulation, what we are doing, we are downloading, right? We are running the image, and we are operating over the image, right? Now, assume Docker was not in the picture. These steps of deploying or creating the image, installing packages, libraries, all has to be done manually. By whom? By your ops team, which is a very, very difficult process, right? And this is where DevOps, like Docker and containerization overall, sort of supports the DevOps ecosystem, right? So you don't need this anymore. Why? Because you're already doing it in an automated manner. You just write a Docker file and all your work is done, right? Cool. So again, there was another important concept that I will just cover in very short, which is basically, let's say there are different runtime, as I mentioned, right? There is container D, there is EXL, there is runc. So again, there can be a conflict between these runtimes as well, right? While you work with orchestration. So for that purpose, we came up with something known as Open Container Initiative. So what it meant was, it defined, again, this is just to learn, for you guys to know about this. Now will not be implementing it right now, but just it's good to know, right? So what does it define? It defines that it defines our runtime specifications, right? Which is runtime spec and image spec, which is nothing but our image specification. Clear? Cool. So let's jump in back to the presentation. Let me take a few queries as well. uh, cool. So yeah, that's how container virtualization works. The benefits, I've already covered them, right? So this is what is happening. I already cleared this, right? There's a client server architecture happening here, right? So we have this client where we are running the commands. It goes back to daemon. Daemon search our local system for the images. If it finds it, it pulls back and it shares. It runs that image, and if it does not find, it goes back to globally and searches for something which is known as a registry, right? These are all registries if you see here, right? And we have different registries. In the registry, we have multiple repositories, or you can say organizations who hold different repositories under which we have different images, and we can use those images directly. I'll give you a hands-on demo in some time, right? um, cool. So any queries? Let me just check. Okay, what is an hypervisor? Hypervisor is nothing. It's used to create a virtual machine, Shashi. That's it. Upcoming session is tomorrow on Kubernetes. Audio. Am I audible clearly? Just let me know if I'm audible. Anybody facing any issues with the audio or something like that? Just ping me in the chat, maybe. Cool, cool. Works fine. Let's move ahead, right? So I hope everything is clear so far, and we'll jump into the hands-on experimentation now a bit. Cool. Again, let's say this is again an example of how it works on OS X and how it works on Linux, right? In Linux, again, because it was Docker was built upon Linux, right? Difference between virtualization and containerization, it's nothing. It's just that we are becoming independent on operating system. That's it. And in containerization, our application runs in an isolated environment, which is irrespective of whatever is happening around. And virtualization, that was not the case. We had a dedicated operating system that was working specifically to run that application. That's a major difference. Cool. So again, if you see in Linux, the Docker architecture, I think we have already covered the Docker architecture. Again, this stream is recorded, Anuradha. If I go back right now, it will take a lot of time, right? You can check out the YouTube video as well. I'll probably share it in the stream, in the channel. Again, there's nothing much if I have to summarize. In Docker architecture, we have three major components: the runtime, the Docker engine, and orchestration, right? So runtime, we have different types of runtime, which helps us to facilitate different Docker commands, which is like the communication medium. And when we jump in back to Docker engine, we'll understand Docker engine in some time. And containerization is nothing but it's just a process which is helping us to manage containers for facilitating the ruling updates, right? Tell us something about Docker Compose. Docker Compose is a bit advanced topic. We'll cover it in the next session. I'm not sure it's near your name is Pomimi, but yeah, we'll cover Docker Compose in the next session. We'll cover Docker Compose when we talk about Kubernetes. That's it. Cool. Moving ahead. So again, I think we have already now how to install Docker. Of course, the major query, right? How do we work around with Docker in Windows or in Mac and everything, right? So let me share you the link. Um, you can directly go to just say download Docker, right, in Google, and you'll find um, the installation guide. So let me share the screen. Yep. So this is a installation guide, right? So this is where I download Docker Desktop. Now again, how do we work upon Docker from Windows and Mac, right? So what are the different mediums? So Linux, we don't really need anything, right? We can directly work around with Linux, let's say, because Linux facilitates Docker directly. For Mac, we can use Docker Desktop, right? That is the best way to go ahead with working on Docker, and also the Docker CLI. And for Windows, we can use WSL, right, and Docker Desktop, both, right? So again, based on your system, you can just move ahead, download, right, and fetch in the updated release. How to Docker log in Docker repository, I'll show that in just some time. So it's not like Docker repository. It is more about the registry where your images are stored, right? So what is a registry now? Registry, you can consider it to be like GitHub, right? Where GitHub you store your source code, right? Similarly, there's a registry. It's known as Docker Hub. Let me share that as well. Right. So yes, this is the first page. Docker Hub Container Image Library, app containerization. So this is where you store, your images, right? So let me sign in. Let's say, okay, I have already signed in another window, so I'll not sign in here. But again, you can just create an account and then get started with it. I'll show how to do it in some time. Right, amazing. And how to log in into Docker registries? So we have something known as Docker login, right? So you just write that command in your terminal, Docker login, and that's it. Once you install Docker CLI, so the first step is to install Docker CLI, and then you just add Docker login, and you just add your username, your password, and you're good to go. Cool. Amazing. So let's jump into a bit about the concepts. So what are images, right? So images are read-only templates that are used to create containers. You already know this now, right? Now images are created basically with Docker build command. So we use this build keyword using Docker to build an image, right? And images are composed of layers. Okay, so what is this layers? I'll explain you when I go for a hands-on demo, right? And these images are something that are stored in the Docker registry. Let me share the screen. I'm not sure the screen was visible. Yeah, exactly here. So yes, images are composed of different layers, right? And what are these layers? So basically, I'll cover this topic in some time when I go to the hands-on demo, right? So a Docker image is not about only particular files, right? It's a combination, or it's a storage, which is like the image is created with the combination of more than 2 3 files, or maybe hundreds of files, right? And those files are known as layers, right? And you'll see those layers downloading to your local system when you run Docker command. So I'll show that in some time. And these images are stored in the Docker registry. They have their own size. They have their own, based on like we try to develop lightweight images so that it can be easier for user to use those images for their operations. And that's it. And what are containers? So let's say, as I mentioned, right, if an image is a class, the container is an instance of a class, a runtime object, right? So containers are nothing but lightweight and portable encapsulations, which are used to run applications, right? That's it. And containers are created from images, right? So when you run an image, you are able to, so whenever you run an image, it basically creates a container, right? And inside a container, it has all the binaries, the dependencies, the libraries, and everything that needs, that are required to run that application. That's it. Cool. Now, what are registries and repositories? So again, a registry is where we store our images, and you can use Docker Hub. You can use other registries as well. You can explore in Google, right? And inside that registry, the images are stored in repositories. So you can basically create repositories and then store those images with tags. Now tags define the versions of that image, latest version 1, 2, whatever you call it, right? Now again, Docker repository is a collection of different Docker images with the same name that have different tags. Each tag visually represents different version of the image that I already covered. Cool. So why we use the official images now? While working with, you'll see that when we work with creating a Docker file, we use official images. Let's say Ubuntu, will use Ubuntu latest, right? Why? Because the official images have clear documentation on how to use them. Now they have a dedicated team for reviewing those images, and there are content security update in timely manner, right? So let's say if I create an image right now, the security, the efficiency of that image, or how to basically run that image, how to operate upon that image, the documenting all of these things can be a very mammoth task, right? But for an official image, there is an entire dedicated team which works on it and clearly documents it, and it becomes easier for as a user, for me to use any official image to sort of get my work done. But can you create your Docker contain Docker image yourself for any particular system? Yes, you can basically, like you will see, we have something known as base image, and we can ourselves also create base images, okay? But nobody's stopping us. But again, a lot of things come into factor. We have security, we have the updates, and like of course, let's say Ubuntu is updated, right? They have changed the release versions. I'm not sure if I'll be changing the release version of my image with the same time frame that Ubuntu has changed. So that becomes a difficult process in that case. Cool. So I see a lot of questions. Suppose you have 3 containers running, and out of those you wish to access one of them. How do you access a running container? I'll show that in some time in the hands-on demo. How do you to delete a stop container? We'll run through them in some time. How is Docker different from other containerization method? Docker is just a tool, right? It's just a tool, and it facilitates containerization. So containerization is holds some a concept, and Docker is a tool which facilitates that. Docker is a tool that actually came up or sort of evangelized what containerization exactly was. You got me? Cool. So let me jump in to my terminal and share some code with you guys, right? So let's jump into my terminal. Okay. Can I use JSON instead of YAML for my compose file in Docker? Not recommended, because YAML is something that we have already adapted, and there are a lot of advantage I covered in the last session. Check out the YouTube video; it's available. Um, cool. So I'm in my terminal right now. Let me just zoom in a bit. I hope my screen is clearly visible to all of you guys. Let me do a bit more. Cool. I guess this much works fine, right? So let's say I want to run an image, and let's say I want to run an image name known as Hello World, right? How do I do that? So Hello World is an image, right? Maybe stored somewhere, right? And I want to run it in my systems, and I don't have that image in my systems right now. How do I do that, right? So I'll say Docker run Hello World. So it says unable to find Hello latest locally. Okay, sorry, I misplaced this. Yeah. So unable to find hello world latest locally, and it will jump in and find. So let's say error response pull access denied from hello world repositories, right? So again, let me check what was the name. Let's try with something else, right? So let's say Docker run, let's say MySQL. So MySQL is hosted in Docker registry, and let's try to run this. So it says unable to find MySQL latest locally, and now it is pulling it from library MySQL. And if you see, there are multiple, uh, you know, there are hash values here which are downloading right now. What are these hash values? This is nothing but the different layers. Okay, so as I mentioned, right, an image is composed of different layers, and these are those layers. So let's say, why do we need these layers? I'll tell you in some time, right? So again, MySQL, the size, we can check this out in the registry, but it will take some time to download all the files and everything, and will pull that image for me so that I can work upon it, right? So let me start a new terminal till the time it downloads this. Cool, amazing, right? So let's say I want to do something else, right? I wanted to play around with, let's say, Ubuntu, right? How do I do this? So I say Docker run Ubuntu, and it's kind of running. How do I check it? So Docker, yes. See here, okay, Docker containers. Just a minute. Yep. What is happening? Cool. So let's say we want to see the running Docker containers, right? So I can just say Docker container. I'll say ls. And if you see right now, this is a Docker container that I'm running for my, it's just it's a status is up to 2 days. It was created 3 weeks back, and this is the current running, container, right? Now let's assume how to see all the Docker. Now you can use a desktop as well. Let me show you a bit about the Docker desktop. So if I say Docker, let me start my daemon. So let me back to the dashboard. Yep. So if you see here, these are the different containers that have been running, right? Ubuntu latest, MySQL latest, Ubuntu latest, right? There are a lot many images that I created, right? And I can check out these images here. What are those different images, right? So this is the desktop of Docker, right, which we can use. And let's say the MySQL, it was not there previously. I just use it, like sort of installed it right now, right? Sort of pull this MySQL image, right? Cool, amazing. And let me try some running, Ubuntu maybe. I say Docker. So let's say I want to work around with Ubuntu, but in an executable format, right? I want to check, I want to jump into that. Like this basically works like this, right? So let's say image, right? And in the image, my application is there where it is running, right? So I run this image, it's great. But when I am trying to, let's say I want to see what actually is happening in that image, I want to track it. How do I do that, right? So we have this command, which is like Docker. Um, So let's take an example. Just a minute. Cool. So I have all my, I guess I'm not logged into my repository. Let me log in. I cannot do that right now, so I'll not be able to show that to you guys. So basically, I am logged into another Docker registry right now. This I'll not be able to showcase what I have in my personal registry. No worries, but still, let's try to sort of catch up with the thing, and I'll try to sort of yep. So let's try to run Ubuntu from the and see what actually happens. So I'll say Docker run /IT, which is interactive environment, and Ubuntu, right? And if you see here, let me exit and show this again. I'll say clear, right? So yep. So I'll say Docker run -IT Ubuntu. So what it will do is it'll create an executable environment for me, right? I'll just jump into the image and see what is exactly happening there. And if you see, I'm into the image right now. So if I say echo, hey, I am Dhruva. Hey, I'm Dhruva. Right. So I'm in my Linux system right now in a Linux container, and I am able to work around with it, right? So let's say I create a file. Um, let's say I call it Vim, or let's say I call it echo. I am Druba. Now, if you don't know how to write this, check out the video that we had made in Linux, the stream that we had in Linux. We have already covered all these topics there. And I'll say um, demo.txt, right? So if I do ls, you see here, I will have my demo.txt available, right? Now let's say I want to access or sort of I want to share this image of demo.txt, where the Ubuntu image or demo of where I have demo.txt to my friend. How can I do that? So for that, something we have basically we have something known as commit, right? So what will I do here? So let me again sort of exit back from here, and let's say cool. um, So again, how to do a commit? So I'll just check out the container ID here, right? I'll copy the container ID, right? And I'll say Docker commit and then I'll give a message, say add what? Let's say hey add demo txt, right? And then I'll put his ID, and then I just run it. I'll not run it right now. Why? Because I don't want to sort of add this to my container ID right now because it is running some other files. So I'll not deep dive into that. But yeah, you probably got the idea, right? Again, playing around with Docker fire commands, you can sort of run through them. We'll also share a cheat sheet where you'll have everything, all the commands listed down, right? So let's try to do something, right? Let's try to create a Docker file from scratch and sort of upload it to the registry, right? So how do we do that? So let's say I create, let's me go to my desktop, right? And then let's say, yeah, Docker demo, cool. And then I create, um, so right now, okay, I did it wrong. I have to go to Docker demo, see Docker demo, and cool. So if I do ls right now, I have my Docker file, and we'll try to edit this, right? So let's say make Docker file. So I have my Docker file ready. So I'll try to run a very simple command. So let's say from Ubuntu, right? So from Ubuntu, it means nothing but Ubuntu is my base image, right? And I'll say cmd, and I'll say echo a I am Proba, right? And I'll say run sudo. Okay, let me see if we can play around with something else as well. Just a minute. Cool. Let's just go with this, and I'll save this and quit. And cool. So if I see cat Docker file, you'll see from Ubuntu CMD echo I'm Dhruva, right? And that's it. Cool. So let's see how to build this one now, right? So for building the image, we have something known as Docker build. If you remember, we have a command known as Docker build, which will build our image for us, right? So how can we run that build, image? So there is two different ways, right? So we can directly say Docker build T. It will directly build the image that is in your current directory, or you can also mention the image name, right? So let's say you have an image name in your mind, and how you can sort of play around with that image name. So you can do that as well. So we will try to use our image name. Just a minute. Cool. So if you see, our build is completed, right? And okay, it says filter protocol failed to get Docker file. Okay, let me check. Let me check. Um, okay. Okay. Got it. So let me try running something else. Um, echo. Cool. Right. And we try to, let's try to save it to a text file. Let's say hello world.txt. I'm just trying to cover all the functionalities in the same place, and then say cmd, say cat. That is a command which is displaying a file, right? And we'll say cat display us hello world.txt. Cool. Looks fine. Amazing. And we can also define the version. So let's define the version. Let's say 14.04, right? And I can also add my address here, like the labels. Basically, you can consider it. So let's say maintainer code with proof. Cool. Looks fine, right? And let's save this, and let's try to run this one now, right? So I've saved this and quit. Let me jump back to my terminal. Here, Docker build, and that's it, right? Um, so if I try to push this now, how do I do that, right? Let's try to understand that as well. So I'll just have to say Docker build my image name. So let's say my image name is something like my image. Okay, say t my image and dot. That's it, right? And the image is built, right? And if I have to push this, I can, again, for pushing I have to create a registry, right? So let me jump back to my Google Chrome once again. Cool. So if I go to the registry once, and let me jump back to my another window, and if I jump back to Docker registry now, So if you see here, I have multiple repositories, right? If I just move to repositories, I have multiple repositories, right, which I can use. I can create a repository, give it a name, and use that name, right? For now, I'll use a sample name because I'm already logged in, right? So let me try using a sample name, or maybe not, right? Let's keep it for the next session because again, that is not my registry. I'll skip that for now, right? Cool. So again, it's just that you create a registry name, use that registry name. If you again jump back to here, you see that there's a command, right? Docker push new repo name and tag name. So new repo name becomes your image name, right? And then you can give it tags as well. So if I say, let's say, test Docker, right? And if I have to push into .test Docker right now, I just have to say, Docker push test Docker and my name, test Docker, and the tag name. That's it, right? And before building as well, I have to define this tag name. That's it. Cool. Amazing. So yep, that is pretty much it about today session about Docker. Again, you can jump into more as how you can learn about Docker and how to play around with Docker and everything. But yes, if I have to give you an overview, whatever we covered today should be enough in terms of getting started. And now the next thing for you should be maybe just jumping into topics which are like using image, playing around with images. If you have an application, try to containerize that, right? And that's how you can sort of play around with it, right? Cool. Any questions, anyone? If you have any questions, feel free to just ping it in the chat. I'll be there in the stream for more 5 minutes and then we'll end this up. Okay. Is there a way to identify the status of a Docker container? Yes, we can run. We have commands. I'll share the cheat sheet with you guys in the channel, and you can just sort of check this out. We can check the container which is running. We can check the container which is stopped. We can delete the containers. We can remove the containers, right? We can remove the images, basically, not the containers, right? Of course, when the container is stopped, it is there is nothing like a running container anymore, so you cannot delete it. And also, you cannot delete a running container. So let's say if I'm running a container, I'm trying to delete it, that will not be a successful operation for me. Cool. Should a non-tech like me become a developer like you? I'm not sure. Depends. If you love this, of course, why not? How far do Docker containers scale? They scale amazing. Again, with orchestration into play, that's the best practice that we have right now, right? Again, there are many other topics like chaos engineering that comes into play for scaling, right? But yes, like using orchestration tools like Kubernetes and Docker, you're good to go. You're like in the updated industry. Cool. So if you don't have any queries, we'll wrap this up, right? You can check out the repositories and everything. Let me share you all the links. So just a minute. So you can check out the blogs and everything around the DevOps Bootcamp here, right? And you can check out the GitHub repository here. Let me show you the GitHub repository as well. Uh, DevOps Bootcamp. Cool. Review. So I have pasted the link of the GitHub repository here as well, right? You can check that out. Use the resources and let me know if you need any other resources apart from that. We'll also have, what else do we have? Yeah, catch up in the community profile because that's very important. That is where I'll post all the updates and everything. So feel free to catch me up in my community profile. Of course, you're connected with me in LinkedIn and stuff, but Commudle is a place where we are hosting everything. So why not connect there, right? And see when is the next session? It's in the tomorrow, right? Tomorrow it's on Kubernetes, and we'll also cover different topics like namespaces and everything. Amazing. I don't think there is anything else apart from that. Check out the YouTube streams, in the YouTube channel, the previous streams as well, so that you are catching up with the entire bootcamp. We'll have multiple sessions in the upcoming days. So if I have to give you an idea on the different sessions, let me share my screen again, and so it'll be much easier for all of you. sort of track down the upcoming sessions. So if I just move to um, Commudle Developer Networks right now, events, and if you see here, we have DevOps Bootcamp day. Um, that's a day 6 introduction to Kubernetes. That's tomorrow, so feel free to register for that, right? And then we have managing Kubernetes cluster in Lens. So Lens is a tool that we'll be using to manage our Kubernetes cluster. Then we have Monoclete tutorial on the 28th of November, and that's it, right? And then we jump into the month of December. So just back-to-back events, right? Back-to-back streams. So catch up, and feel free to share in different like you can take a screenshot of this right now, the screen, and feel free to post it in LinkedIn, Twitter, wherever you want to share, like, and become part of the learning in open initiative. Hashtag DevOps with Commudle, and tag me, tag Arpan, tag Commudle, and share your feedback, right? So yeah, thank you so much for joining in this stream as well, and let's catch up tomorrow again, and we'll learn Kubernetes. Right? Thank you so much, guys.